Hello guys, welcome to 2020 Data Orchestration Summit. In this talk, I will introduce the Alluxio usage in our platform, and I hope this is helpful. Zhang come from China Unicom, the world's fourth largest telecom operator. I'm working with Spark, Flink, Alluxio, and other big data systems. In Alluxio community, I have some experience in Alluxio kernel and system operations. I will give the talk in 3 parts as follows. At first, let's look at the background. Why Unicom needs Alluxio? Data analysis system in China Unicom used to be built by every single business group. Different business groups chose different systems according to their business demand and engineers' technical capabilities. There are 3 major systems. First, the Greenplum. Some business groups use this to deal with bench jobs with strict deadline. This MPP database has great speed. Working on SQL is efficient, especially in distributed scenarios. People all love it. But as data grows, the cluster size reaches the bottleneck. The open source Greenplum is not able to handle a scale of more than a few dozen nodes. The business group was eager to increase their cluster in scale. Hive. Some business groups use this to deal with N+1 bench jobs. This kind of jobs have a looser deadline. Resource consumption of these jobs is large and they are slow. As for Oracle, some business groups use this to deal with traditional data analysis jobs. Due to standalone performance bottlenecks and high process, these groups wanted to move to a better system. In order to satisfy demands above and make it more efficient in resource utilization, we decided to build a unified computing platform with Spark ecosystem to hold all business jobs above and share computing resources between different groups. Why we need Spark? First, Spark is more scalable than Greenplum. Second, Spark consumes less resource and is faster than Hive. Third, Spark is cheaper and deals with much bigger data than Oracle. Plus, a unified computing platform has better resource utilization. There were 3 challenges from building the unified computing system with Spark on Hadoop. First, performance on Spark doesn't compare with the speed on Greenplum. Ad hoc queries are too slow for the business users. Second, this architecture lacks stability. Multiple runs interactive jobs are prone to failure. We brought in Alluxio as a cache layer between Spark and HDFS to speed up performance. We expected Alluxio could speed up read and write performance, improve write stability, and taking over Spark cache to enhance Spark jobs stability. Then let's talk about Alluxio usage and business improvement in China Unicom. Our architecture looks like classic big data architecture. The Hadoop Arc is more scalable and flexible than Greenplum. The original data comes from Oracle, DRDS, Kafka, and text files sent by SFTP. After ETL processing, we put them into Hive and transform data format from text to org. We added the Alluxio layer to make Spark comparatively fast as Greenplum. Platform users read base data from org table and put them into Alluxio for data prepare. Business Spark jobs directly read and write data on Alluxio. Business result data will be stored in HBase or written back to Hive. As an important on Spark-only architecture, we introduced Flink and Presto later to handle stream scenarios and ad hoc scenarios. Platform users use Jupyter, Hill, and Zeppelin to query data. The platform is a part of Unicom's private cloud Tiangong that offering a unified portal for users and providing a native integration with China Unicom's monitoring platform, Kenya. Iterative computing is the most typical scenario. This business logic is the same as the procedures in Oracle. In this scene, upstream sync will be a part of source for downstreams. Most of things will be reused, and the timing of the data read is predictable. We keep sync data in Alluxio in memory to speed up downstream reading. This also significant improve data thread stability. We use Alluxio to take over Spark cache. This strategy is effective especially in situations with a large amount of data. As data growing, Spark cache will not speed up effectively, but will significantly increase executors' memory usage and out-of-memory rate. Organizing intermediate data in Alluxio have stable and efficient performance, while users just working with normal Spark SQL API. Having multiple replicas significantly improves how data access speed. Alluxio has many tools for users to manage data replicas. Users can define a range of replicas for specified paths. A background process will maintain the replica count. When users wanted to load data from UFS, they can define replica numbers as they needed. Alluxio also supports pinning the specified path. This feature is useful in super high data access scenario. The free API gives users the approach to release Alluxio space. This API works very well on interactive computing scene. Users free data when they no longer need it. This approach improves memory utilization. In high concurrency access pattern, we also want to limit the number of replicas. In this pattern, the block replicas will quickly occupy the Alluxio space, which exceeds the requirements. Meanwhile, there will be a great competition on UFS block query that significantly affect read speed. This is usually occurs where multiple apps want to fetch the same metadata block. We can use deterministic hash policy on client side to deal with this pattern. This policy is able to determine the number of Alluxio workers to read block from UFS. The competition and memory usage will be effectively reduced. The amount of I/O in different Spark executors usually has a big difference. This can easily cause cluster data to skew. To adjust the data distribution strategy for load balance, there are two policies available. Most available first policy aims to use the cluster space to the max. It will pick the most available worker for clients to read-write data. This policy works great on cluster where workers have different capacity. But in a high concurrency pattern, this policy may lead overload on the most available worker. Round-robin policy is able to avoid the risk of worker overload. This policy will distribute your data uniformly, but will not use the cluster space to the max. Users may choose appropriate policy in their case. Alluxio brings performance with increased stability, as we can see in the form. Compared with Spark and Hive, executors GC time, task runtime, and job runtime effectively reduce. And jobs will not fail and restart after using Alluxio. After migrate to the unified platform, there has been a significant improvement in business performance. The size of core bench business has increased sixfold while speed up by 100%. Core ad hoc business processing 10 terabytes of increasing data and running TB-level data queries in minute level. Our platform now supports business use cases with much larger datasets. Alluxio 1.x has a successful usage in Unicom. Alluxio 2.x even brings a more significant all-around improvement. Alluxio 2.x implements a built-in high availability function based on Raft algorithm. This feature makes it possible to get rid of Zookeeper and makes it easier to deploy Alluxio HA on cloud. The most useful feature in Alluxio 2.x definitely is store metadata using RocksDB. This is a great enhancement to metadata operations. At first, it improves the performance and stability of recursive operations in the 100G plus dictionary. We don't need to worry about out-of-memory error occurred on Operation Large Dictionary. Operations TB-level dictionary is safe and will be completed in seconds. Secondly, it reduces the impact of files inconsistency. At Alluxio1.x, if there are a lot of files which are inconsistent with UFS, Alluxio master will crash if we fix inconsistency directly. So we need to fix in batches, but there will still be a few situations that we have to deny all users access to avoid master crash until all inconsistency has been fixed. Where the enhancement of master's ability. Dictionary in TB level, which contains more than 10,000 files, can be fixed within 10 seconds. The whole process was very smooth, and that the unrelated users are not aware. When Spark writes too many files into Alluxio1.x, there will be a considerable time consumption on files moving out temporary directory. This process can take several minutes. Alluxio2.x reduces 19% time in write block waiting time in our case. It's a significant improvement on computing performance. With the platform is accessed by more and more users, storage space is becoming more and more tight. Alluxio2.x supports mounting multiple HDFS with different versions. This feature makes it possible for users to migrate their apps to HDFS3 UFS with very little work. Alluxio usage and business improvement in China Unicom has become introduced above. Now let's summarize. Alluxio accelerates Unicom's Spark bench processing and ad hoc services to ensure business stability and efficiency. The specific approaches are: first, share Spark data with Alluxio to speed up business pipelines and reduce the chance of job retrying. Second, users improve their app performance by ping, controlling the replicas and write data strategies. Third, apps improve resource usage by activating free. Plus, read and write strategies can also be used to ensure that the Alluxio client is load balanced. In Alluxio 2.x, enhanced Raft high availability greatly improves metadata operation performance and availability. Mounting multiple versions of HDFS help users to migrate their apps to the HDFS3 with very little work. At the end of the talk, we welcome you to join the community. Thanks for listening.